Are you ready, kids?
Aye, Captain.
Oh, I can't hear you.
Aye, Captain.
Oh! Who doesn't ever get a chance to leave his classroom because he's always here? Me. Anyway. All right. Anyway, I know it just got dark. Anyway, all right. I know, right? I couldn't actually keep going with that. All right. Okay, find the area of the graph's two functions by partitioning the y-axis. So now we're actually doing the y-axis ones. Okay, I saved this one to have its own day because it's kind of a pain, and a lot of people, I really don't think we address this enough, because it could wrap around the y-axis, or it could wrap around the x-axis, or either or we have rotations around the y, rotation around the x, and those are the ones that usually get people. It's not the x-axis ones, it's the y-axis ones, because you have to think about it differently. All right, so now, if I were to shift this over, and I'm just going by from the y-axis here, my y-axis would be from, okay, remember, you're always going to go from the smallest to the greatest, right? So that would be from where to where? On the y-axis, where would this be from? C to D, from C to D, right? So from C to D, which one's going to be the top value? Which one's going to be the larger x values? If you think about it, when I'm doing it around the x-axis here, okay, I'm finding the area between the x-axis. So I would normally try to figure out which one has the greater y values, right? But now I'm doing it around the y-axis, and so now I need to look at it to see which one has the greater x values, right? The greater x values are going to be the ones on top. So this would be the function of, yeah, so it would be the red one, right? So the red one minus this thing right there, right? So that's how I would actually go through and do that. I would partitioning it that way. So it would be the top minus the bottom. So I actually have a function on this next one. So for this one right here, it's f of y is greater than g of y for all numbers in the interval from c to d. So it's the top one minus the bottom one. But it's for the y values. So let's see if that will make a little bit more sense when I throw some numbers in here. Find area A of the region enclosed by the graphs here. So it has f of y is equal to y plus 2, and g of y is y squared. So to find the area enclosed by that, that means I need to set them, say equal. Set them equal, right? So it's going to be y plus 2 equals y squared. 0 equals y squared minus y minus 2. So that factors out to be don't everyone speak at once on this one. What does it factor out to be?
Y
Minus 2 and? Okay, so that means y is 2 and y is negative 1, right? Okay, so those are the two places that it's actually going to intersect. So negative 1 and 2. So I know that it's going to be enclosed in there, right? So from what? Did I miss something? Oh, dang it. Okay, I missed that one. All right, so from there, I got to figure out which one of these functions are going to be on top. So in between there, what should I do? Plug in a number, right? In between there to see which one's going to be on top. So let's say we plug in 0, If I plug in 0 here, this is 2. If I plug in 0 here, that's 0. So therefore, f of y is going to be on top, right? Okay, so now it's going to be my y plus 2, right? Dy minus my y squared dy. Okay, we're going to come up with y squared over 2 plus 2 y from -1 to 2 minus my y cubed over 3 from -1 to 2, right? So it's minus all that, so basically parentheses there, remember? Yeah, all right. Because we're going to be subtracting those. All right, so right now, I want to see what you guys get on this. So everyone is calculating right now. Did we get it yet? All right, you ready? What do we get? 4.5? Everyone agree? Okay. Yes, no, maybe? Okay. Alright, let's take a look. Oh, hey, look, there's a graph too. So you guys can see what it looked like. Now these ones right here, find the area of the region enclosed by those two and the x-axis. And the x-axis. So we're going to partition it. So we're going to do it according to the x-axis, and then we're going to do it according to the y-axis. Okay, so let's go ahead and start by graphing these. So root 4 minus 4x. And the other one is supposed to be tab, what was the other one? 4 minus x. Ah, dang it. All right. So the x-axis is going to be one of my guides here, right? Okay, so now right here, so we have an intersection right here at 0. So at 0, they're both 2, right? So it's going to go from here down to here. So it's going to be the shaded spot right in here. Yes? Okay. So according to the x-axis, it would be from 0 to what? 1, 2, 3, 4, right? From 0 to 4, right? Okay, from 0 to 4, and it's going to be the red one minus the blue one, isn't it? Okay. Okay, so let's go ahead and set this up now. All right, so red one minus the blue one. So it would be integration from 0 to 4 of, no, on this one it's blue minus red, sorry. Yeah, the other one it was red minus blue. Okay, so that one's going to be right. All right, what do I have to do here though? To be able to do the integration, what's going to happen? What has to take place here? Use up. Okay, so on this one, you would be what? All that, right? Negative dx, right? So it would be, sub it out for a negative du. So it's going to be integration from 0 to 4 for a negative u to the 1/2 du. Yes? Okay, let's do the other one then. So for this one, my u is going to be the whole thing again, right? So u is 4 minus 4x. du is negative 4 dx. So I'm going to have minus integration of, let's see, I have negative 1 over 4 of u to the 1/2 du. Yes? Oh wait, 0 to 4. Yes or no? SMH? You're not shaking your head? Are we okay with that? Or okay, it does work, right? Okay, now do the math. Anyone see that it doesn't work yet? Yes. Actually, I do. It's more of a napkin, but. Anyone yet see it does not work? Trying to give you a hint, it's not going to work at a certain reason. The second part. Can I plug in 4 for the second one? Can I plug in 4? What's going to happen there? Yeah, so it's going to go into the range in which that it's not going to be allowed, right? So that one has to go from where to where? It only exists from 0 to 1, right? That's what has to change. Because it doesn't exist outside that. Did we get an answer yet? Help me out, so I can help you. Where are you at? Are you okay with the integration? With the use? Okay, because we can't do the integration of this, so I use subbed it. So I use subbed it, I turn it into this, and so now it's this. So can I take the integration of that? Yeah. Add 2 over 2, and then divide by it, right? Yeah, so this is going to give me negative u to the, and so reciprocal of that, right? So it's going to be, because you're going to divide by 3 over 2. So it becomes 2 over 3 here. And that's from 0 to 4. Yes? And then it's minus the other side, 0 to 1 of u to the again, so it's negative. You could take that out and make this a positive. Right? Because there's a negative here, I could take out the whole thing. And so that's going to make this a plus. that's going to be what do we come up with?
Eight, maybe.
8?
Maybe.
996.
It's because it's not bounded, so you just have to take the interval.
Hmm?
From 1 to 4, it's not bounded because there's no.
Oh.
From 1 to 4, you just have to take the interval.
Oh yeah. So hold on. Let me see. Let me go at it from here. So where am I going? I'm going here. Uh, 4 minus 4x or just x? This one's just x, right?
Yeah.
Okay. There we go. Just 4. All right. So we did that one. Now, what would I have to do to turn it into around the y-axis here? Okay, from the y-axis it starts at 0, right? And it goes up to 2, doesn't it? Okay. So this one's going to be a little bit easier to do. So I'm going from 0 to 2, and it's the top one, which is going to be the blue. So right here. So turn it into an x equals. So y equals 4, radical 4 minus 4x. So y squared is equal to 4 minus 4x. So y squared minus 4 equals negative 4x. Divide by negative 4. That's going to give me 1 minus y squared over 4 is equal to x. Okay, that's where we got for one of them. Here it is, right there. And the other one, y equals radical 4 minus x. Y squared is equal to 4 minus x. So y squared minus 4 equals negative x. So x equals 4 minus y squared. That's where we get that one. So again, right here, this function, this one's actually going to be easier because just top minus bottom, and they both have the same points of intersection on the y-axis here. So it would be from 0 to 2, and it's the top, so it's going to be 4 minus y squared dy minus 0 to 2 of my other one, which is 1 minus y squared over 4 dy. Again, this one's going to be simpler. They have the same bounds. They have the same bounds, so I could combine them into just one function, but I don't. It's going to be a pain, you know, because that fraction. But life happens. So 4y minus y cubed over 3 from 0 to 2. And this is going to give me y minus y cubed over 12 from 0 to 2. All right, calculate this part. Did you guys get 4?
Yes.
Are you working on 4? All right. This one, find the area enclosed by the graph. I'm not gonna have enough time to finish it, but I will set it up. Y equals ln x. And the x-axis and the line x equals e. So, let's see. X equals e. So 1, 2, 3. What's the value of e to the first? 2.7. So it's like right about here, right? So this is E. Okay. And y equals ln x, region enclosed. So there's the graph of ln x. Something like that. Okay, so find area A enclosed by that. The x-axis and the line. This. So it's asking for the area right there. What would be the best way to try and do this? If I were to do this around the x-axis, that would be what? 0 to E, and that would be the graph of ln x dx.
So ln at 1 is 0, graph is 0, 1, x equals 1.
ln of,
Oh, so it shifts.
oh, yeah, sorry. It's supposed to be up here, right?
No,
X equals
X equals
or
one.
X equals 1.
So the other, on the
Shift
x-axis.
the graph over 1.
Oh, yeah. Okay, sorry, yes. You're right, you're right. No, I missed something there. Okay, so yes, starts here, goes there. That's what I'm looking for. All right. So, starts there. All right. I knew I messed up somewhere. Thank you. Remind me to give you candy. Okay, so now, does that change it? It changes a lot. So now, that would be from, not 0, from where? From 1, right? Right there. Okay, so I could do that, but what's the integration of ln x?
1 over, oh, no, right. That's very weird.
We haven't done that one yet, have we? No, we haven't done that one yet. Okay, so that's the reason why I wanted to set this one up. So we didn't do that one yet. So what we can do is do this around the y-axis. Wouldn't around the y-axis be a little bit easier? Okay, so if I were to do it around the y-axis, that would be, I would take the, from where to where? Where do these two here intersect? Where does, let's see, ln x equal e to the first? You guys have a calculator in front of you, right? At what? Just plug it in. What's the ln of e to the first? All right, because you're trying to find the y value for this. If I'm going to have it around the y value, I just get 1, right? So I got 1 there. So my value is going to be that. All right, so now that's going to be from, let's see, integration from 0 to 1 of e to the first dy minus 0 to 1 of my, let's change this. So ln x, I said x, come on now. ln, crap. Okay, so now e both sides, wouldn't that be e to the y equals x? Yes. So that's going to be e to the y dy. So I had to change this function right here because I needed it to be x equals. And now that it turns into x equals, is this manageable now? What's the integration of e to the y? E to the y. There we go. Is this easier? Yeah. Okay. All right. Like I said, I was just going to set this one up. All right. Like, share, and subscribe. Don't forget, click here for, extra content, or click here to go to our subscribers page.